You can create simply new virtual machine and attach this disk. Just like in your laptop, desktop, you lost all the hardware, motherboards, RAM, but disk somehow survived. So you can safely remove it and attach it to the new disk, new laptop. So you can recover all the data. But other virtual machines equally important in order to run our virtual machine successfully. So you can see first file we have, that's extension is VMX. It is called configurations file. All kind of virtual hardware information, what operating system you have selected, Linux, Mac, Windows, 32-bit, 64-bit, MAC address, that all information we can find here. And this is editable. You can open it in a notepad. Sometime we needs it to open it and make some changes inside the VMX file. And these two files, swap file. Can you tell me what is the size of this swap file? What is the size of this VSWP file?
10 GB. It will be the same as the virtual memory.
Yeah, same as the virtual memory.
Same as the allocated memory to the VMs, right? If it is a 10 GB, it is a 10 GB. Allocated memory 1 GB, so it's a 1 GB. And second is VMX.VSWP. What is the purpose of this file? What is the size of this file? Before lunch, we discussed the overhead memory. If you configure virtual machine with 1 GB RAM, 1 virtual CPU, overhead memory 20 MB. So this is for overhead memory. A very heavy contention, too much pressure on the physical RAM, it can swap your overhead memory also in this file. So its size, that depend virtual machine overhead memory 20 MB, it's 20 MB, 50 MB, 1 GB. As per the overhead memory per virtual machine, we can find this swap file. And this is .NB RAM. It is known as a BIOS file. Whenever you make any changes regarding the BIOS of the virtual machine, those changes get written in this .NB RAM file. This file itself not representing BIOS, but in the BIOS of the virtual machine, whatever changes you have done, that changes it preserve or write in this .NB RAM file. And many times we have seen in almost all the module vmware.log file. And what is RDM disk? When this file get created? Do you know the concept of RDM?
Once the physical hard drive or hard disk is connected to the VM, then only this to basically to this ESXi, then only this will be created.
Yes. So first of all, we have ESXi and we have some roll-ons. Let's say LUN2 we have inside the storage. And when you make visible, first of all, to the ESXi, now this LUNs, you do not need to format with VMFS. When you're going to deploy virtual machine, you can create virtual machine with RDM disk. Pick up this LUN, attach this directly to the VM as a RDM disk. So the virtual machine in this case doesn't have -flat.vmdk because this raw LUN directly you mapped to the virtual machine as a disk. So what file system this LUN2 going to have? Yes. What file system this LUN2 base storage contain? Because this time you are providing this directly to the VM. VM using it. So what do you think? What could be the file system we have, which we formatted this LUNs to? Is it vSAN? Is it a VMFS, NFS? What it is?
I think it will be VMFS.
VMFS is the file system of your ESXi, but you presented this to VM. If you present this LUN directly to the VM, now by using which file system we are going to format, that depend upon the OS. If it is Windows, so Windows going to format this LUN to with its own NTFS file system. If it is Linux, ext3 or not VMFS, because ESXi not going to format it. VM going to format it. You have several use cases, like you want to make active passive failover cluster, Microsoft failover cluster. So two different virtual machine, active, standby, but both accessing the same LUN. Active goes down, standby become active, and you have the same database accessibility. Or I have a SQL Server physical, whom I'm using this LUNs as a database. So when you convert this physical machine to virtual machine, that I'm also create a new virtual machine without any disk, power it on, and attach this existing LUN to this VM through RDM concept. So whenever we create this RDM disk, then this file get created under the same directory rdm.vmdk. This is also known as proxy file. So we're making impression for the operating system that this is your disk. So it generates its read write to this rdm.vmdk, and hypervisor intercept those IOPS of the virtual machine and then write directly on this physical disk. And when we're going to use RDM, you have two options, P and V. Are you going to attach this RDM as a physical or virtual? Physical, if you select, then at the VM label, where you have this disk RDM, you cannot perform snapshot. But if you want to take a snapshot, then we need to use the V parameters while you are attaching flat.vmdk virtual. So it means in the future, anytime you want to take snapshot, yes, it is supported. P required for some like Microsoft based application, they must need to use the P. So in that case, we cannot take any snapshot at the VM level. And you can see next few files belongs to your snapshot. And before that, we know very well what is flat.vmdk and simple vmdk, that is descriptor file. This is also you can open in a notepad, WorldPad, very small, less few KB only in a size. So it keeps the information about flat.bmdk, which disk virtual controller you are using. Have you start editing, writing on the flat.bmdk or not yet? So that information we can maintain in a descriptor file. And this is belongs to your snapshot, VMSD, VMSN, and first this is a main snapshot file. If you are using VMFS version 6, so it is sc_sparse.bmdk. If you are using VMFS version 5, so in that case it is a delta.bmdk. Per delta per sparse, it has one descriptor file. And whenever you take a memory state, also capture in the snapshot. So, and we do not have just these. You can find some more files. It depends what technology, what feature we are using. Like if you're using a backup application, you also integrated with the vSphere environment. So you can see .ctk file, .lck file if you power on the VM. Locked file, yesterday we discussed. But yes, for most of the virtual machine, these are some common files you can see. And the most important file, flat.bmdk, vmdk, vmbeer.log get automatically generated, swap file get automatically generated, and vmx. So these are the common files we need in order to successfully power on the virtual machine. So where we can find virtual machines, all files. So in which data store you have your virtual machine, and this as per the display name virtual machine, you can find same named folder in the data store where you can see the virtual machine related all files. Changing, moving, deleting VM files can cause virtual machine to become inoperable. Other files are created as the VM is maintained, managed over the time. VM files are created at the flowing point. When a VM is powered on, we know very well, LCK file, vmbeer.log file, these both swap file, and VRAM file. We can see when you power off VM, powered on VM, the existing vmbeer.log get renamed and archived like 001, 002, 003. Maximum it can maintain 8 files. And whenever we put virtual machine in suspend state, so you can put files inside the same virtual machine folder. The flowing files are created based on the type of disk that you create. As I explained, when you use the RDM gives you two compatibility mode, virtual or physical. V and P. Virtual supports snapshot, physical doesn't support snapshot, but yes, if you want to use the RDM for Microsoft failover clusters, you must need to use the physical mode only supported. So whenever we use this RDM, you can see -RDM.vmdk proxy file get also created. VM snapshot files are created for each snapshot depending on the VMFS types on which VM is located. VM snapshot files for VMFS 6 data store or any VMDK equal to or larger than 2 terabyte on the VMFS 5 data store. So single sparse.vmdk maximum you can have 2 terabyte. So that depends whether it is sparse or it is a data. VMFS version 6, so you can find the snapshot file names, and per snapshot file you have one descriptor file also. But if it is a VMFS version file, then same snapshot file name is data.png. And then additional things that depends whether you're going to capture a memory state also. Are you going to pop out the snapshot questions? Not really going to see that also. What does it mean? You have two additional check marks on this one and this one. These both are optional things. VM snapshot key integration. If you have multiple snapshots, snapshot 1, snapshot 2, snapshot 3, if you open the snapshot related descriptor file, then you can find which snapshot is the parent for whom. With the help of this child ID, parent ID. Initially, for the first date, it showed to be the parent ID FFF, but child ID is 0A. And this parent ID, this child ID, you can see it becomes the parent ID for the next snapshot. You can see 0AA at the last, and after one more snapshot, you can see whatever child ID you have here, that becomes parent. And this is a unique ID. And this is a child ID. And whatever child ID you have here, F36, that becomes the parent ID. This way we can identify who is parents for whom. When you run the script, it's going to change this ID. What you can do, manually.
Okay, what is the job profile?
You can open, first of all, download these all files in your desktop, open in a notepad, WordPad, and match these child ID, parent ID. Something missing, manually you can edit those, and then again save the changes, put back into the same location of the virtual machine directory, and you can see your virtual machine again start working without any problem. Based on information in this descriptor file, what are the names of the first and second descriptor files? So you can identify them. This file 1, this file 2, or this file 3. And based upon their child ID, parent ID, you can easily identify. And F36. So this is the parent to this one, and this snapshot is parent to this one. You can use parent file name in parameter to determine the name of the parent descriptor file. So which one is the parent to which snapshot file, that we can take the help of these parent ID, child ID, parent ID, child ID. So this is the child ID, become the parent ID, and this child ID become the parent ID. So now we're talking about OS state. If your virtual machine is powered on, you're taking a snapshot, you can see there are two check marks. One, are you going to capture the memory state also in the snapshot? Or most latest information you want to capture in the disk. So what happened when you have ESXi? This is a physical RAM, and we have we have a flat.vmdk disk in the storage. So over the period, this is a mail server per minute, 10 mail coming to this is a mail server. Lot of data it maintains in the physical RAM as a buffered data. Then from the physical RAM, it writes it to the flat.vm. First, it keeps the incoming data in a RAM. Then from the RAM, it goes to the flat.vm. So when you're going to perform a snapshot while virtual machine is powered on, and in the snapshot, you want to capture latest data in flat.vm because capture in the snapshot the